So we're continuing with Math 125 review questions. Question number 4. This is Fundamental Theorem of Calculus, Part 2. The theorem says if f is a continuous function on interval I, and we define the accumulative sum function f of x equal to integral from a to x of f of t d of t. See, the pink ones are the dummy variables. And then the derivative of this accumulative function is going to be actually f evaluated at x. Things to notice: that a, when I'm taking the derivative, that a counts as a constant. It can be any numbers or so on and so forth. So now let's do one example with a function that is continuous everywhere and see how this derivative thing works. So first thing is this function. And what I think is, when I'm taking derivative from a to x, the derivative of top is basically 1. Therefore, there's no, I don't see the effect of chain ruling here. But when I'm really taking derivative of this entire thing, I should think of it as the accumulative function. So let's try to do it that way. So I'm going to replace this by the cumulative function evaluated at x to the 5. Sorry, one step is missing. So first I rewrite it as the accumulative function. So I find something in between. I can find, let's say, 0 in between, or any number in between. And I go, this integral is integral of, let's say, 0 to x to the 5th f of t d of t minus integral from or minus x squared to 0. Oh, has to be a plus in here. So the lower and the upper, and lower and upper, and these two kind of blend in together. D of t. And now, to make this the accumulative function, I have to notice this is really integral from 0 to u. So this is f of u. What is u? U is x to the 5th. So I'm writing it again. Let's rewrite it over here. That becomes integral 0 to u f of t dt plus, and now, one thing, u is x to the 5th. Now this one, I want the variable on top, so I switch the lower and the upper bounds. But when I'm switching the lower and upper bounds or limits, then I have to change the sign. So this becomes a negative sign. So I'm putting 0 on the bottom and negative x squared on the top. Again, I want to look like that. So let's call this g. And g is equal to negative x squared. And g. Now, this is a cumulative function at u, f of u minus, this is a cumulative function at g. This has become because u is a function of x and g is a function of x, and we're taking derivative with respect to x, we are using chain rule. Now, so this becomes like dx of f of u minus dx of f of g, and that's the derivative with respect to u of f of u, f times derivative of u with respect to x minus derivative with respect to g of f times derivative of g times with respect to x. That is derivative of f with respect to, this is f of u with respect to x is just lowercase f of u. So it becomes f of x to the power 5. Derivative of u with respect to x is 5x to the power 4. Derivative of f with respect to inside of it, again, is f of g. Derivative of g with respect to x is negative 2x. So this was a good example, but the function, and this is the final answer. The only thing is that the function was f. So the next part of this, the same example, I'm going to erase the board and put a function in here. Very complicated function, but it doesn't matter. And we continue with that. So now I replace that f of t that was continuous everywhere with 1 over 1 plus arctan squared t. Arc tan of t to power 2, basically. So this is a composite function inside, and then the very inside is arctan of t, and arctan of t is continuous everywhere. The denominator is always positive, therefore the entire function is always continuous. So continuity checked. The function inside is continuous. So this should be, I didn't even change the limits, so this should be very similar to the problem I just did before, except that instead of plugging in values into f, I'm plugging values into arctan. Now, so the next step is, from what we just did, I remember that when I'm taking a derivative of this, and the limits have changed from here, what I need to do is I have to remember to plug in the limits and do a chain rule and then subtract. So it will become plugging in the limit into here, the upper bound is x to power 5, the entire thing to power 2, then derivative of inside, which is 5x to the power 4, then I subtract, this time put the lower bound in, then multiply by the derivative of the lower bound. Negative 2x. And this is the solution to taking the derivative of that cumulative function. Things to notice is if you try to take the derivative of this, you can even use a machine to do it for you. It doesn't have an elementary solution. That means that the functions that we know is not going to be an antiderivative of this. Therefore, taking the antiderivative, then taking the derivative doesn't work. In the methods that we know, in future we learn methods that actually would work. But it's because we're taking the antiderivative and then the derivative, it's an easy problem to solve.